see a question where we have to show that tan of 5 theta is equal to 5 tan theta minus 10 tan cube theta plus tan raised to 5 theta whole upon 1 minus 10 tan square theta plus 5 tan raised to 4 theta, and we can apply De Moivre's theorem. Now the question is, if you will see the De Moivre's theorem, it is cos theta plus I sin theta raised to n, which is cos n theta plus I sin n theta, and here our question is in terms of tan. So how to get it? So it's simple. If I want to apply De Moivre's theorem, then by De Moivre's theorem I'm gonna get sine and cos. So to get the tan, I'm gonna divide sine with cos, because sine upon cos is tan. So since I want tan 5 theta, I'm gonna find out sine 5 theta and cos 5 theta. I will divide it, and by that I'll get tan 5 theta. But guys, let's see the right hand side. So on the right hand side we have powers of trigonometric function. So it is tan cube, tan raised to 5, tan raised to 4. Whereas on left hand side the power of tan is 1, that is tan, only tan. But the angle is 5 theta, which is multiple. So it means left hand side is multiple of theta, right hand side is powers of trigonometric function. So this question belongs to a concept which I taught you just which I just taught you in the previous video. So according to that concept, we will apply the different steps to get the answer. So step number 1 is we apply De Moivre's theorem. Now here I want this multiple of theta as 5 theta. So the power of that complex number is gonna be 5. So here I'll say so here I've applied De Moivre's theorem. Now step number 2 is we will apply the binomial theorem. So here I'll say now how to expand this by using binomial theorem. So we are going to revise the formula which we have seen in the previous video. So here we have completed step number 1 of De Moivre's. Now we are in step number 2. So by binomial theorem, if first term is a and the second term is b, then we start with a to the power n. So highest power or whatever power is given here, we take it as a power of first term, and then we reduce that power in each term. So a raised to n minus 1, n minus 2, and so on. Similarly, power of b we increase by 1. So here it is b raised to 1, which is a 1. So b raised to 1, b raised to 2, and so on till b raised to n. And with each term we add a term of combination, or we multiply the combination term, which is nc0, nc1, nc2, and so on. So I'm going to use this formula here. So by doing that we will get cos raised to 5 theta plus nc1 cos raised to 4 theta I sin theta, next plus now guys, here I have applied the binomial theorem. So, but you have to observe one thing, that everywhere I am writing nc1, nc2, nc3, and guys here we have already defined n as 5. So instead of n we will call it as 5. So this will become 5c1, this will become 5c2, 5c3, then 5c4 and 5c5, because the value of n here we have considered as 5. Now let's take all real terms together and all imaginary terms together. So cos raised to 5 theta is real term. So here I'll go on the next page. So here I'll write cos raised to 5 theta. Next, This is imaginary term because we have I in that. Here I square is negative 1. So this is gonna be a real term. Now I square, since it is negative 1, I'm gonna take negative sign over here. Next, the value of phi c2 is 10. So that will become 10 cos cube theta sine square theta. This one again imaginary term. This is real term. I raised to 4 is 1 and phi c4 is 5. So 5 cos theta sine raised to 4 theta. So here we get all real terms. Now let's take imaginary terms together. So phi c1 is 5 cos raised to 4 theta sine theta. I'll take I outside. So plus I. Next 5c3, it is also equal to 10. So 10 cos square theta. Now I cube is minus I. So we have taken I outside, but here we have negative sign. So this plus will become negative. So minus 10 cos square theta into sine cube theta. Next, this one phi c5 is 1, cos raised to 0 is 1. I raised to 5 is positive I, where we are taking I outside. So we'll just get sine raised to 5 theta. So plus. So guys, this is the separation of real and imaginary part, and I'll call this as equation number 2. Now let's see left hand side of equation number 1 and 2. So it is exactly same. So we can say that right hand side is also same. But on the right hand side, we have real and imaginary part, and similar in the equation number 2 we have real and imaginary part. So it means if we are equating right hand side of both equations, we can equate real part with real part and imaginary part with imaginary part. So this real part is cos phi theta will become this, and we can equate the sin phi theta with this. So here I'll say from equation number 1 and 2, so these are the values of cos phi theta and sin phi theta. Now let's find out tan phi theta. So tan is sin upon cos. So here I'll say therefore tan of 5 theta is equal to sin of 5 theta upon cos of 5 theta. Now let's substitute these values here. So I'll write down the value of sin phi theta in numerator and cos phi theta in denominator. So we will get now if you see the answer of tan phi theta, then it is in terms of tan, whereas we got answer in terms of sine and cos. Now the simple question, if I want to convert these values from sine and cos to tan, then how to do that? So we know that tan is equal to sine upon cos. So it means if we bring cos in the denominator, then we can get tan as a value. So for that we have to divide this numerator as well as denominator by the cos term. But now question is, what should be that cos term? Should it be cos theta or cos square theta or cos raised to 3 theta? What it should be? So let's see that. So if I take that denominator as cos cube theta, then what will happen? So here I write down that statement. So by doing this, we will get tan of 5 theta equal to, so this will become 5 tan theta minus 10 tan cube theta. Here sin raised to 5 upon cos raised to 5 will be tan raised to 5 theta. Next, cos raised to 5 theta upon cos raised to 5 theta is 1 minus this term upon cos raised to 5, so cos cube cancels, sin square upon cos square is tan square, so minus 10 tan square theta plus, now this upon cos raised to 5 theta, so cos and cos cancel, sin raised to 4 upon cos raised to 4 is tan raised to 4, so 5 tan raised to 4 theta. And guys, if you will see the question, then we have proved that value by using De Morgan's theorem. So I'm sure that you understood how to convert multiple of theta into powers of trigonometric function. And if you want to learn more videos on engineering mathematics, then don't forget to visit ekeeda.com, because there you can meet me and you can watch all my videos at one place. Thank you very much and all the best.